And video. Perfect. And my hair is not. Great. And recording has started. Let me go ahead, share my screen. Oh, could you allow me to do screen sharing?
Yeah, let's see. Sorry, I've not done this for a while. Where do I do that?
That's a great question. When I see it, it says host disabled participant screen sharing. I wonder if you click on the participants list, if there's a way that you can give me permission from
That's
there.
where it is. Yeah. I made you a host, which means you can probably do anything now.
I hope so. Let's see. It still says disabled. I know that we're recording. Host allows you to record. Okay, that's one thing. Oh, when in doubt.
I thought that would allow you to. Oh, let's see. Yes. Oh, okay. Maybe now can you?
Let's see. Yes, that was it. Nice.
Okay, great. Thanks.
Thank you.
Mm-hmm.
Okay. Let's do the entire screen. Good. And okay, let me just get back to here. Start back here. Okay, I am now ready. So I think we'll just go ahead and get started. So hi everyone, my name is Andrew Nicols. I'm gonna make this thing go smaller though. Perfect. Welcome to Powering Off Grid, a comprehensive guide to solar and storage. Thanks so much for being here on at noon on a Saturday. So I know we all probably have other stuff, but I've been really looking forward to teaching you guys and also learning from you guys as well. If you've got a smartphone, you can scan this QR code, and this is a copy of the presentation. So if you ever want to take a look at this presentation, I'm going to be working with the library to make sure that it gets linked on their website. But this is a nice way for you to get that presentation if you'd like it. I know I've.
Oh, are you gonna put it back only because I turned my phone on?
Yeah, no, that's fine. I just. Yeah, and at the end of class, I can always go pull this up again. We've got 2 hours. I think we're gonna have plenty of time to cover through the topics and to do our live lab. So I'll just go ahead and get started with my introduction. So I'm Andrew Nicols. I've been living on the island for the last 7 years, as some of you guys know. And I am kind of this cross between an avid environmentalist and also a science techie sort of geek. I got involved with solar because my wife, Rachel, she works at Take It or Leave It. So she's in charge. Anytime you drop off clothes or a microwave or something like that, she's the person that is organizing it, handling all the volunteers, etc. And she presented me with an opportunity last summer when I've been talking about, my house has solar. I'll actually switch over to the next one. Yeah, so my house has solar. I'm in the middle of the forest, but I've got enough daylight actually coming in where from May till October, I'm 100% solar powered. So I got introduced through solar as, hey, I want to reduce my energy consumption. I'm still on grid, but I wanted to be able to provide excess back to the grid. And especially during the solstice, like June 21st, I'm providing 200% power. So I get to offset not only my house, but another house. Pretty nice, I like that. But ultimately, I wanted to drive myself towards more of an off-grid lifestyle, be able to provide 100% sufficiency for all of my needs. This is where I got started. This was done by Rain Shadow Solar over on Orcus. So they helped set up this whole system. And one of the reasons why I wanted this is, well, when we have power outages during the winters, I need, my water is off of a private well. So once that pump goes out, I can't flush the toilets. And, I'm fine with, starting up the wood stove and using flashlights and things like that. But if I can't go to the bathroom, that's kind of a big deal for me. So this was my first step into solar, was a grid tied solar connected system. But when my wife had presented me the opportunity last year, she said, hey, a couple of solar panels came in. They said it works, but I don't know how well they are or how good they are. And this kind of started my learning journey for the last year on, what can I do with secondhand, recycled solar panels? Something that no one really wants. Can they even be that useful? So I'll go back. This started my journey on trying to figure out how to do off-grid solar. And so I run a business here on the island called Lopez Tech. I help people out with their computers and printers, and I fix smartphones and tablets and all this sort of stuff. If it's something that has technology in it, I can probably learn how to fix it or how to make it work or optimize it. So a lot of people tend to refer to me as a tech wizard. So I kind of have a little bit of an analytical mind, but I feel like this is a lot of me talking up my ego. So I apologize about that. For my house, I've got 8 kilowatts of grid tied solar, and I'll get into explaining any of these terms. When I use terms like energy and power, or kilowatts and kilowatt hours, who does know what those terms mean? And this is the perfect class to be able to understand these things. I don't expect anyone to have any of this knowledge, but it's nice to hear that some people do know some of these things. I think this is going to be a learning journey for all of us today.
I mean, I know it's a measurement, but I don't really know what it's a measurement of.
Sweet. Yeah. And we'll talk about exactly what that measures and how you can kind of map that in your head when you hear something like 1 kilowatt hour. What the heck does that mean? So we'll cover that. I've got my solar shed here. So this is an older photo. These are the first 2 panels that I got from Take It or Leave It. And I built what I call the solar shed. This is where I store my e-bike outside. Welcome, come on in. This is where I store my e-bike, and this is, I took these secondhand panels and had to make some sense of them. How do I use these for recharging my e-bike? I've ridden 1,500 miles on that e-bike. It was a birthday gift for me. I wanted an e-bike, but I hated lugging that battery back into the house to recharge it. I wanted something really convenient where I could ride my bike around on the island, just park it in the shed and plug it in and have it charge. But of course, this shed doesn't have grid power. I could run an extension cord out to it, or I could figure out how to use these secondhand panels and get the energy myself without having to run an extension cord across the yard.
Those are the little tiny panels.
They are very tiny. Yeah, right up here, these little guys, they're little babies. So with this, I've expanded up to a 2 kilowatt hour energy storage. There's that word again, kilowatt hour. And then all throughout my property, I've got solar lights because I've got metal sidewalls for my buildings. I took these little Amazon solar lights and I attached magnets to them so that I can just pop it on the side of those buildings without having to drill anything in. So I've got a whole bunch of different little solar things throughout my property. And it's all part of this kind of initiative to not only understand solar, but also to reduce the amount of energy that I draw from the grid. Before I get into learning more about you guys who are all here attending, I want to give a special thanks to 2 organizations. First, PhD Energy. I was at a trade conference in Atlanta, I think back in March. And as I was going around this giant expo floor, PhD Energy were there, and they were showing off some of their products. And one of the things that they had, which I'm so excited about, is they had sodium ion batteries. Has anyone heard of sodium ion batteries? I've heard this in a research capacity. Oh, sodium ion. But here is a company that is actually producing not only sodium ion cells, but also sodium ion packs where it's drop-in ready. And I've actually brought one here, so we'll take a look at that later in the lesson. But I want to give a special thanks to them because they provided me a battery free of charge just because they knew that I was going to be teaching and educating people, and they wanted to help support that. So PhD Energy, thank you so much. I also want to give a thanks to the Lopez Solid Waste Disposal District, LSWDD, because they run Take It or Leave It, and that's where I got my solar panels from. That's the start of the my independent off-grid solar journey. So thanks to them. So now that I've kind of covered those things, I want to learn more about you guys. So who here already has solar? Yes, you guys. Now, I did talk to you earlier. You guys, as far as I understand, are already off-grid.
Correct.
Yes.
Yeah.
That's great. How long have you been doing that for?
Since 1993. Wow.
And when you did that, you were using solar or any other energy generation?
I was using solar, which at that time, there was not these big, large solar panels.
Yes.
I had 5 50 watts solar panels.
So you had 250 watts of total energy generation on a good day.
Yes. And we still do have backup for the winter, which is our little Honda generators.
Yes.
That'll keep our banks up to healthy.
And for energy storage, I think, did you mention you're using AGM batteries?
No, I had AGM up until last year, and I switched over to lithium iron.
Yes.
Not iron. There's a big.
Yes, there is a difference.
And we are using those now. And that was the first time since 1993, after I installed the first 2 batteries, that I had a blackout.
Because you had to disconnect your batteries.
No, because I had the wrong control.
Oh, it wasn't set for charging a lithium iron phosphate.
Not set for that.
I think this is great. You're bringing up all these juicy keywords that we're going to be talking about. So lithium ion versus lithium iron phosphate batteries, charge controllers, wattage. There's all these terms. It's really great. Can you remind me your name?
Corwin.
Very nice to meet you.
Some people call me Martin.
What do you prefer?
I don't care.
Okay.
As long as I'm there for you.
Good. And how about you, sir?
This is my 5th year.
Okay, so you've been doing it for the last 5 years. And then what's your system? Where do you get your energy from?
It's all from the sun.
Okay, so you're all solar.
I have the same generator he does, a 3,000 watt Honda.
For backup, right? For topping up those batteries, especially when it's a cloudy day or if it's winter, right?
Yeah, he's on water catching up.
Mm-hmm.
And also, I'm on composting toilets. So if you have a problem, get a composting toilet.
Yes, that is a great suggestion. Okay, great.
So what I did is I drove a well, and when I was out west, I saw these solar panels, Solar Direct, that recharge stock tanks.
Yeah.
And I took the notes on the label, and that's what I do. So when the sun shines, my well pump puts it into a 1,100-gallon storage tank, and then gravity down to my place.
In essence, you're taking solar energy and converting it into gravitational energy. You're pumping that water up into a tank, which then
It isn't up quite enough though. I can run a couple of things, but if you hold the hose up this high.
Yeah. No, it's okay. So it doesn't have a lot of head strength or pressure.
9 and 10 PSI, which is.
It's a little, but it's enough for you. You two are off grid. It's enough for you guys to live as you wish, right?
You know, one of the things, I don't want to talk at length here, but I've always kind of been street legal and decided to go ahead and apply for a building permit.
Yeah.
And I met with the most amazing kinds of opposition that I never thought I would encounter. Like, they want me to meet Washington Energy Code,
Mm-hmm.
which would, I talked to people that designed that, and they don't have no provision for off-grid.
Yeah, it is.
They say it's not viable. You can't do that.
And with rainwater catchment too, this is a bit of an interesting thing. With us taking individual responsibility for energy, for water, we run into opposition from people who aren't educated on how you can do these things safely, independently. There's concerns about meeting electrical code. My intention is, I've got a little disclaimer here. I am not a professionally trained electrician. So everything that I'm telling you here is going to be for educational purposes. It's not like I'm a licensed person to be able to do this. However, you can do this safely. And this is part of that thing with that opposition is if you can demonstrate that your system is safe, that it may not be done to code necessarily, but if you're off the grid, I don't know what legal recourse that they have if you're not connected to a grid structure.
I'm definitely, I have LNI inspection. I'm trying to be as safe as possible.
Yes.
It absolutely is to code, but their demand that I meet their energy standards. I try to explain to them I'm not taking any energy, so
yeah.
any day of the week I'm using less than you are.
Mm-hmm.
And one of the requirements would require me to add twice as many panels as my power requirements.
Yeah.
So I don't know what I would do. Maybe I'll get an electric car someday.
Or an e-bike.
Yeah, e-bikes are great.
Yeah.
But I mean, it was kind of stupid.
Yeah.
And they wouldn't bid on it. So probably I'm going to get down to that, and that'll be the last battle to get the building permit. I may not get the building permit because I don't meet their, kind of expansion requirements.
Hey, can you remind me your name?
Bob,
thanks so much for sharing your story. I think it's important to hear stories like this because there are different levels of this, right? And I'm going to be showing different levels of, do you want to dip your toe into solar and energy storage, or do you really want to go more legitimate as you've talked about? I do want to hear a couple of other people. Who here is interested in off-grid for their house, their boat, their RV or camper? Okay, great. Do you guys want to tell me a little bit of your what interests you?
I'm rebuilding a second home and I just want to go off the grid, but I'm not doing it as part of the construction. I'll do it after the fact.
Okay.
So I'm setting up the generator backup now.
Okay, cool. So it's not all in one time. It's kind of this journey, and I'll tell you that's the same for me, right? How about you, sir?
I'm trying to figure out what type of system I want to design.
Yeah.
If I want to go back into the grid or off grid totally, or a hybrid system, I'm not sure.
Awesome. We'll cover a lot of that. And back here?
I'm just gonna build a studio and I wanna not take any more electricity to, fire that up, so.
Wonderful.
New building.
Yeah, no, I love that. I love, my plan is to get sheds throughout my 5 acres, and I want each one to be just totally off-grid. So there's a lot of kind of similar dreams in that respect. Now, for the other people who haven't spoken, what's brought you in today? What are you interested in?
So, I've just I have a lot of experience with wind and solar generation on boats, pretty much.
Okay.
But I don't have any experience with homes, and in the future would like to learn more about that and possibly implement it here.
Okay, great. That's awesome to hear. I'm gonna go to the gentleman in the back. Hello.
Yeah, I just popped in because it seemed like an interesting subject and was trying to educate myself. I don't really have anything going in solar direction, but
I think that's great. One of my favorite traits of people are curious minds. You saw that there was this class, you decided to pop in. So thank you so much for being here. For you two.
I'd love to understand, yeah, the terms more, because I hear it.
Mhm.
So I do have a small home in Arizona, but it's all electrified.
Yes.
But I do have the air conditioner heater, what do you call those, mini splits?
Yes.
It can be hooked up to solar. And
Yes.
so I'd love to have just the basics and get a couple used panels and hook it up down there. And for here, I'm just setting up on a lot, and it has electricity to it already, but I don't really wanna, I'm using it just as a tent kind of shed. And so I'd love to just be able to have solar in that shed in the tent. So just during the summertime. And then I don't have to move into a Papa and pay all year.
Yes. Yep. That totally makes sense.
Yeah, yeah. And so this is perfect timing because I just got here and I haven't.
And these are our sunny months too. So this is the perfect time to really get started. And how about you?
Yeah, I'm just down the road from you, and John and I need to build a bunch of outbuildings this summer.
Okay.
And most of it's gonna be kind of on the grid, but thought it was a worthwhile thing to kind of explore.
So you're gonna be a shed builder. This is good to know.
Hey, yeah. Well, I want to thank each one of you so much for being here. I'm really excited to talk to you guys. I'm excited to talk to you guys about this. So I guess without further ado, let's talk about what our lesson plan is going to be. We're going to talk about all the different types of off-grid solutions that you can get, from commercial stuff all the way to do-it-yourself. There's a lot of stuff that I'm going to be teaching you guys about do-it-yourself solar. I'm going to be talking about how does solar work. I'll talk about it really simply. I'll talk about it at the chemistry physics layer. It's pretty nifty stuff. I'll also talk about how batteries work and all the different types of batteries. We've heard lithium ion, we've heard lithium iron phosphate, right? I'll talk about all of these. We'll also look into, great, you have this power. Now, how do you power your things? How do you power your stuff? Whether it's an electric vehicle, it's an e-bike, it could be a well pump, it could be lights, whatever it is, I'll be talking about how you then take that energy and you then turn it into work. Then I will talk about how do you make this safe, right? Here are all the things that I've learned when I build a system. This is the stuff that I do. You can make it really cheap, but it gets a little bit riskier. And so I want to teach you guys about how you can make it safe. And then lastly, we're going to do a live practice. And awesome, the sun is out. So we'll be able to do measurements and test things, and we'll actually get hands-on experience with building this. So if you've never built solar before, you're going to have an opportunity to. Cool?
2 hours?
Yeah, an hour and a half now. So let's cover off-grid solutions. There's kind of 3 categories I've made. There's the professional grid tied, like my house has. There is an all-in-one unit. These are commercially available under a whole bunch of different names. And then there's the do-it-yourself solar system. So for professional grid-tied systems, my recommendation here in this area is Rain Shadow Solar. They were the ones that set me up with a 13 kilowatt hour energy storage system and 8 kilowatts of solar on top of my house. Any excess energy that I generate goes to the grid, and that goes to other Opalco customers. I get credited for that. I was lucky enough to get grandfathered in, and I'll explain that a little bit more in detail if you're curious, but essentially for every kilowatt hour I use and every kilowatt hour I generate in excess, cancel each other out. So in essence, I've reduced my energy bill by about 50%. It's the winter months that really kind of kill me. But I've been able to do a one-to-one, energy credit. Opalco has net metering options. That's what I'm talking about. I'm tied into the grid. My excess goes to the grid. That's called net metering. How much I use, how much I generate, that net is what's getting metered. My warning to you is, unless you are a qualified electrician, do not connect your do-it-yourself solar system to the grid. And there's lots of safety reasons for why that is. There's also inspections and permits and other things that need to happen. But if you're off the grid, that's fine. So pros for this, you can get paid for excess power with a grid-tied system. You can also run household appliances on solar. Now, you can certainly do this with a do-it-yourself or even an all-in-one system, and there's been a lot more push and movement from those all-in-one systems for, hey, you can run your house off of this, and it's really easy to get it, approved and up to code with those all-in-one systems. The cons for doing a grid-tied system is it's expensive, you can't really do it yourself, and you have to have a grid connection. So if you're on a boat, or if you're in an RV, or you're building a shed that is, 1,000 feet away from your house, you have to have a grid connection if you're going to do a grid-tied system. So if we talk about professional grid-tied systems, I was telling you that there's reasons for why you shouldn't do it yourself, safety reasons for why you shouldn't do it yourself. In this image here, we have, let's say, a do-it-yourself solar that someone's built, and they're connected to the grid. There is a windstorm, power goes out. Your house, however, is still generating electricity. What makes this dangerous is because your house is generating electricity, there is active electricity on the line that can affect a lineman working on trying to repair the grid for everyone else. And if you are back feeding, that's this where you are providing electricity to these wires where it should not have any, you could electrocute a lineman. So it is very important that whenever you're on the grid, that you have the ability to island your system. Islanding is very simple. It is a switch for your house that detects when the grid goes off, then it automatically disconnects itself, and you can generate electricity and use it for your building, for your RV, your camp, whatever, but it doesn't affect the lineman anymore. So this is how you prevent backfeeding. It's how you island your system so that way it's all safe. What about all-in-one solutions? These are really convenient because you don't have to go buy all these separate pieces and understand how they interconnect. You just buy the one thing and it's all ready for you to go. This is what I would call a commercial off-the-shelf solution. You can just go online, go buy one, ships to you, go plug in your stuff. It's all ready to go. Makes it very simple to get into off-grid solar. You're just kind of limited on flexibility. There's no mix and match with these types of systems. Can't really do batteries from this company, you can't do batteries from that company and have them work nicely together. You kind of have to pick a brand and stick with it. And there's lots of reputable brands. There's Anchor and EcoFlow, Jackery and Goal Zero. These are guys that have been doing this for years and years and years. And there are also other brands, but these are the ones that I personally know of and can attest to their quality. They're also spendy. Since it's an all-in-one system, you're not getting the cheapest price for all these things. So when I typically purchase these things, I'm looking for a big discount, a big sale before I purchase one. They're also pretty bulky. If you're trying to integrate this solar energy storage into a boat where you have very limited compartment space, then these systems might not work well. But for an RV, for a cabin, certainly, it'd probably be fine because you're not so space constrained. They're also very portable, and the thing I've recently started experimenting with is you can use these to recharge an electric vehicle. So electric vehicles, I've had my Tesla for 5 years now. I've done 70,000 miles in this car. 100% solar power, woohoo. But if I were to ever run out of power somewhere, that vehicle is stranded. And unlike a gas vehicle where you can just go get a gas tank and fill up the car, what do you do with an electric vehicle when the nearest charger is a little too far away? Well, you can bring the charger to you. So using one of these all-in-one systems, I can just say, hey, can you come pick me up? My car is stranded over at the ferry. Oh, no problem. I'll go load in my battery, I'll go bring it over to my car, and I plug in my car into one of these batteries. So not only can I collect all that solar energy and put it into this thing, but because it's portable, I can use it for other things other than just being locked down to that building or vehicle.
Does it weigh?
You want to see? So, pardon me. This guy, this is a tree pollen dusty guy. This is the EcoFlow Delta Pro. This is one of their highest end systems, and this is
60 pounds.
Yeah, go ahead and feel that battery.
Yeah.
Yeah, so
It's got wheels.
Yes. Yes.
Okay.
Thankfully, with a system like this, they give you this really nice leverage. So having a long lever like this with wheels at the back means that I can roll it around. But something like this is pretty heavy. So let me go ahead and
So that would charge your Tesla?
This would charge my Tesla.
20 miles, a few hours.
Yeah, so this is a 3 kilowatt hour battery. I think it's like 3.5 kilowatt hours. Per kilowatt hour, I can go 4 miles. So I can do about 12, 15 miles with this battery. And considering that the island is 15 miles long, I can get home, right? Well, and the other thing is, I only need to charge the car long enough to get to the village market. I don't plug my car in there, that's a faster charge. So it's a little bit better to do that. So that's an example of an all-in-one system. That's heavy, but it's doable, right? They give you some tools, they have some wheels, they have that nice long little rolling suitcase handle. And that makes it a little bit easier to make it movable. The last category of off-grid solutions is do-it-yourself, right? It's inexpensive to do this. You can scale up to your needs. You say, hey, I only need this much power. I only want to handle this appliance, this electrical load, whatever. You can buy the part that's right-sized for you, so it's pretty cheap. I think for doing my entire solar shed, it was $400. And I don't ever have to pay for recharging my e-bike anymore. All of my electric power tools, I have chainsaws and weed whackers that all use batteries. Well, now those all get charged by the sun. It's also easier to fix one of these systems. When one of those all-in-ones has a problem, you have to call up the company, you have to send it in for repairs. But when it's do it yourself, because you built it, you're going to be able to say, well, I know that I just need to replace this part. I just know that I need to upgrade this thing. So there's a lot more flexibility in the do-it-yourself system, but it's not as portable, right? All of my stuff I've got mounted to walls and things like that. It's not on wheels and has a little handle. It takes longer to build. With the all-in-ones, you can just go click online, and then in a week, you're going to have that thing show up. But with this, you're going to have to spend the time to actually put it all together. And there's also less power output. you know, for kind of the basic stuff that we're going to be getting to, it's going to do a lot of power, but it's not going to power your dryer. It's not going to power your electric oven, right? Those things have such high energy demands that these do-it-yourself systems can do that, but it just takes a little bit of work to get up to that point to build a system that does it. Question?
Yeah, I see that, the picture there. Can you identify, what are like the basic components, identify them and mainly that like white box?
Yes.
Is that like an inverter or?
You are so on point here. Yes. What we're looking at is a device called a charge controller. And I've got sections where I'll talk about each one of these, but this is great that you're asking this question because I'm the type of person that when someone uses an acronym, I focus on what does the acronym mean without like, I ignore everything after that. I'm like, please define it first. So I absolutely am willing to explain this out, right? We've got a charge controller. We've got our solar panel. We have our energy storage system. These are batteries. We have a load. This is some electrical device. It could be a light bulb. It could be a refrigerator. It could be, a bunch of different things. And then we have an inverter, which is going to convert the type of power that is coming from the batteries and converts it into wall outlet power. Thank you for bringing that up. And this is probably a really great time to talk about all of these different terms that I'm going to be using. Now remember, if you have a copy of this presentation, you can always go through and read this stuff later, but let me cover this just so when we use these terms, we're all kind of speaking to the same degree. Yes?
I don't want to get too far off the subject. On the do-it-yourself.
Yes.
You said before. When I set up Rain Shadow, did it for me.
Yes.
You're going to really have a hard time finding anyone like Rain Shadow or Rain Shadow itself.
Yeah.
To come and set you up if you're doing it yourself.
Yes. Yeah. They'd much rather sell you their.
They would much rather do the big jobs that are, because this country is going solar.
Yes. I think that's a really good point. I was fortunate enough to get my solar 3 years ago. But I know that
they're back when John owned the company.
I think so.
Okay. As soon as John retired, the new people.
They're looking for the big jobs.
Yeah, and they won't even back up with John sold.
Mm.
Yeah, I had a little, about a $600 car, and it didn't work.
Yeah.
I called them up, and they sent out someone to check it out, and they said, yep, it doesn't work. And they charged me $350.
Just to come out and say, oh, yeah.
To tell you something you already knew.
Yeah. So it sounds like kind of the reputation of this company may not be as glorious as when they.
Their reputation may be fine and are doing business, have their business plan are going. What we really need in the industry is service people.
Yeah.
People who will go out and help you do the installations. If you run into a problem, like I ran into a problem with my inverter, they didn't send a man. They couldn't send a man out because they didn't have time to do it because they were doing big money jobs.
Yeah. Yeah. And this is, as you guys had pointed out, this country is going solar. Solar since 1993, the cost per watt of energy that you can create or per watt of power has gone way down, way cheap, to the point that you can get, enough power to satisfy an entire household for less than $10,000. And solar panels are typically warranted for like 20 to 30 years, but in reality, they can last much longer. And as build quality has been improving, the expectation is that solar panels will probably be something that you can give your kids and their kids and their kids, and it will continue to produce. So in my experience with getting the little two tiny There, yes, these little too tiny 50-watt panels, they still generate 50 watts. And these are from the 90s, right? So solar panels, 30 years old, can still generate electricity. And if you can figure out how to combine this stuff together, you can take something that would typically have to go to a recycling facility dedicated for solar panels and instead just say, well, it still works. I've got the roof space. Why not use it, right?
And one of the add on to what Martin said is we need to find where, sources of materials and expertise. Like for me to get some additional solar panels without paying a huge shipping charge, I go to Billings.
You go all the way to Montana?
Yeah. And I used to be able to go to Portland.
Yeah.
But they're made in Burlington, Washington.
What? That's right here.
So we need, where do you go to buy a panel?
We got it, yeah. And that's honestly something I don't know how to do, with the exception of online. I don't know of local wholesalers that can sell you, typically when you sell solar panels, you're typically doing this on a commercial installation. So you'll have a pallet with 30 panels. And what these wholesalers don't want to do is break a pallet, meaning that 30 panels on a pallet, but you only want 2. They don't want to take 2 off of that. They want you to buy the whole pallet. So if you can find a wholesaler who will say, yeah, I'll sell you 5 panels here, 3 panels there, when you need it as you're upgrading your system, when you have the electrical needs or when you have the financial means, right? This is the nice thing about do-it-yourself systems is that you can scale it up. But to your point, it's hard finding someone that will sell you those panels in those low quantities. Otherwise, you're probably going to be paying pretty expensive online just to get a few panels.
Yeah, it costs as much as a whole panel, like if you were to buy 2 panels.
Yes, yeah.
Less than, say, 10.
Well, maybe, I think it's great that you mentioned the thing about Burlington, because now I'm going to do a little bit of research. Like I said, I want to teach you guys, but I also want to learn some stuff too from this class. So thank you for your input on that. I want to cover some of these terms that we're going to be talking about. In the electricity world, we have volts. We've heard of a 9-volt battery, right? Or a car battery is like a 12-volt battery, right? A volt is the same. If you think of a hose of water, it's the pressure that is being applied. Your voltage is the pressure in this electrical circuit. Your amps, this is the current. We literally call amps current, but this is kind of the, if you think of a river, right? You can have a really steep river, the pressure, but if you have a really wide river that has a lot of water, that's that current that's being pushed along. And then I've been using these terms. Power, which is kind of this electrical strength. You can figure this out by taking the volts, multiply it by the amps, and you will get the power or the watts. If you have 1,000 watts, you have a kilowatt. So watt is the measurement of power in this electrical system. And then I'll use the term energy when I'm referring to power that's been stored somewhere. So I call this electrical volume. You have a hose. It's got pressure, and it's a pretty, thick hose, but you're filling up a 5-gallon tank, right? That volume of water is your energy. So when we're talking about what's the difference between a kilowatt is, think of a bodybuilder, right? Lifting up some weights, that's power, right? But now imagine doing that for an hour. And that is a kilowatt hour, is taking that measurement of power over an amount of time and saying, hey, there's this much electrical volume in this space. So I've got batteries that are a kilowatt hour. That means for 1 hour, it can provide power at 1 kilowatt. we've seen a 60-watt light bulb, right? I know that we've gone towards LED bulbs, so things are sipping energy now, usually like 2 to 5 watts. But that 60-watt light bulb with a 1 kilowatt hour battery, you can power that thing for about 200 hours with 1 kilowatt hour. When you get billed by Opalco for your energy use, you get billed in kilowatt hours. You, for the month of May, used 500 kilowatt hours at 15 cents. So you pay X amount of dollars, right? So kilowatt hour is kilowatts over an hour. You'll also see like car batteries, they'll be measured in like amp hours. It's a similar concept, and you can figure out what the kilowatt hour is if you know the amps and the volts. So it's a 12-volt battery with a 100 amp hour energy storage. 12 times 100 is 1.2 kilowatts. So if you know the amps and the volts, you're always able to figure out what those kilowatts are. And I tend to measure everything in watts and kilowatts rather than amps, because this only tells you something if you also know the voltage. Yes.
But when you buy your batteries, you're buying by amp hours.
Correct, yes. And so if you're thinking, all right, I've got a 48-volt system, and these are 12-volt batteries, and I am connecting them together in series. If I'm connecting them in series, and they're each 100 amp hours, but I need 48 volts, I take 12, 24, 36, 48. Each one of those batteries is 100 amp hours. I have 48 volts, but still only 100 amp hours. If I took all those batteries and I put them into parallel, I'd have a 12-volt system with 400 amp hours. So this is why I prefer using kilowatt hours to describe something, because you don't have to care about the amps, you don't have to care about the volts. You kind of see regardless. It makes it a little bit easier to.
Really makes it confusing, you know, as you're starting out.
Yes, yes, it absolutely.
Because when you go to buy your batteries, you don't know the watts.
Yes.
Necessarily.
And I think it's a little bit of a frustrating thing, but when we talk about the electrical world from a house outlet, it's a 10 amp circuit, it's a 15 amp circuit. You don't really talk about how many kilowatts that circuit can provide. You talk about, because it's all 120 volts, that never changes. Or cars, oh, this is a 50 amp hour battery, because it's a 12-volt system. So I think now that we're getting into electrifying so many more things, it's useful to have some sort of term to measure these things regardless of its application. Household stuff, outlets here, they provide alternating current. That's AC power. You've heard the band AC, DC, right? Alternating current, direct current. That's where the band got its name, right? So direct current is the type of power that comes from a battery, and AC is the type of power that comes from a wall outlet. We also, as the gentleman in the back had pointed out, we have inverters. Those will convert DC into AC. So it's the way that you can take battery power and turn it into an electrical outlet. We'll talk about strings. This is where you have several solar panels connected in series. We'll also talk about arrays. There's something in series, whether it's solar panels or batteries, that's where one is connected after another, after another, after another. Like in a chain. Each link of the chain is connected to the previous and to the next one. Parallel is where it branches out. And so all of those components are connected to one central point. They're not in a chain. It will hopefully make a little bit more sense later. Wow. There's a lot of stuff there.
Okay, thank you so much.
Yeah, thank you.
I have the kids today and.
Yeah, well, thanks for stopping by.
So.
Yep.
I appreciate it.
Yeah. So let's talk about how solar works. At a simple level, light from the sun hits a solar panel, which creates or it generates electricity. Now, this light is strongest on sunny days, but solar can still work even on a cloudy day. And solar panels produce more power when they're directly pointed at the sun. So where those solar panels are placed makes a big difference in how much electricity they generate. Power flows from the solar panel to a battery to store that energy over the day. And a charge controller is in between that connection. And its job is to make sure that the battery stays healthy. The battery is connected to devices using an inverter. An inverter makes wall outlet power, and power can be provided all day and all night, even without the sun, as long as you have that battery. Yes?
But not all systems are connected to a battery.
Not all systems are connected to a battery. There are certainly examples where you would have a solar panel directly connected to some electrical appliance, but you are going to have to make sure that that solar panel doesn't provide too little or too much power that might burn out or hurt whatever electrical appliance that you have it connected to.
Right, so if you're still on grid.
Yes.
You still require a battery.
If you are on grid, you do not require a battery. That's a great example because now any excess or whatever, that's going right into the grid, but what you are going to have is an inverter. You have to take that DC solar and connect it to the grid by inverting it, converting it, and then at that point, no battery is required. Now, I will warn you, for people who have built, say in California, houses and they built solar on it, PG&E, which is the electrical company down in California, when there are wildfires and they have to take out the grid, a lot of homeowners with solar but no battery were very surprised to find out that their house doesn't get power even though the sun is shining. Those solar panels are preventing backfeeding. The solar panel itself will detect when the grid goes down and they will stop sending power. So these homeowners with solar, that could totally work. If the grid is down, then they don't get power. So this is why having an energy storage system in combination with solar means that if the grid goes down, then your house still has power.
And you would call that a hybrid system?
I would call it a grid-tied system with energy storage. Hybrid is a great term to kind of encapsulate that idea. So we've seen solar panels. I showed you that little tiny one. I've got a couple back here that we're going to take a look at. But fundamentally, how do these things work? There's no moving parts. How does this little, wall panel that's kind of blue or blackish in color, how does it take sunlight and actually turn that into energy or into power, I should say? This is all done through the photovoltaic effect. So photo referring to light or photons, and voltaic referring to voltage. Light will create pressure, electrical pressure, within the system. So I've got a solar panel here, and it's very ugly design, but once that light hits the surface of the solar panel, what's going to happen is an electron is going to move throughout the solar panel into this collector and move back around. This motion of electricity is the power from a solar panel. That little sort of animation there, that describes exactly how sunlight can create electricity in the system. So cool, we've got this photovoltaic effect. We know that light can hit a solar panel and it creates electrons moving through this little panel. But how the heck does that even work? Silicon is a pretty nifty atomic element. Silicon from like sand, silicon dioxide, right? So you can get the material for most of the solar panel through most of the Earth. There's a ton of silicon all throughout the world. Now, in granite and on beaches, and there's a lot of silicon in the world. So this is a very easily, readily available material. But if we look at it from an atomic level, there are these electrons that are all bonded to each other. This is the crystal structure of silicon, and it's very happy. All these electrons are sharing a neighbor. Everyone's really happy. This is a very perfect crystal of silicon. But what we want is we want this light to hit that solar panel and knock off an electron from one of these silicon crystals. Well, there's a nifty thing that you can do called doping. And I'm not talking about the Olympics or Lance Armstrong type of doping. Doping in this sense means to put in a different type of element into the crystal that has a different characteristic. And in this sense, we are going to add phosphorus. And phosphorus has one extra electron compared to silicon. So if we dope half of this panel with silicon and phosphorus, there's these little extra electrons ready to get knocked out from the photovoltaic effect. Good. So we've got a little bit of extra stuff here to start this. But now what we want to do is we want to create a deficiency on the other side. This is called the PN, the positive negative junction or boundary. And what we want is we want extra electrons here, and we want less electrons here. And if we add boron, boron compared to silicon is missing an electron. Here we have extra, here we have a desire for an extra electron to make things nice. Well, because there's this excess and this deficiency, when light hits and it takes one of those electrons, it will want to move to the other side. We have created this imbalance within a solar panel. So when light hits it, it will create this electrolocomotive force. This is great, but when we look at the sunlight that is coming down to Earth, let's take this graph here. It's a little hard to see. This shows for the wavelength of light, how much does the sun generate? Look at this, there's a lot there. But our atmosphere blocks some of it, clouds block some of it. So the actual energy that we receive is less, and it kind of has these dips because of the ozone layer blocking certain wavelengths of light, etc. So this is kind of the amount of light that we actually do receive here on Earth. But in addition, silicon is great because when a photon hits it, it doesn't require too much energy to knock out that electron. The photovoltaic effect can happen to lots of different materials, but silicon is ideal because it captures all of the visible spectrum, everything we can see with our eyes, and it captures a lot of infrared, a lot of this heat energy that we feel from the sun, and it captures a little bit of ultraviolet light as well. So silicon is great because it is readily able to capture most of that sunlight energy. And then the other thing is solar cells in general, regardless of size, they're always going to really just generate half a volt. This is not a lot of power. Half a volt is barely anything. But if you can take a bunch of these little solar cells and connect them together in series, then you can take half a volt plus half a volt plus, and you can get a solar panel with lots of these cells. And a solar panel can generate 12 volts, 20 volts, 40 volts, depending on how many cells that has in total. This is really nerdy stuff. I understand. I'm excited to talk about this stuff, but don't get me wrong. I realize that there's a lot of confusing stuff with this. But the thing that's really important is the photovoltaic effect is when light hits this silicon structure, it creates an electron to move through it. And as that electron moves, it generates half a volt. If we attach a whole bunch of these things together, they all work together to create real usable electricity for our purposes. This probably would have been a better point maybe an hour or two ago, but solar will still work even on cloudy days. This is my grid-tied system. I take every single kilowatt that I generate and I track it and I put it in a spreadsheet, and here's a graph. And we'll see that here's probably the solar solstice in the summer, and then the winter solstice, right? So it will, as there's more sun higher up in the sky for longer, I'm generating more electricity, and as it gets winter, it goes down. But you'll notice all these sharp spikes, and that's cloudy days. Every single time that there's a cloudy day, I'm not generating as much electricity as I would hope to. Cool. So solar will still work even on a cloudy day. Look, there's still about that much electricity that I generated. It's just not as much as I could have been doing, right? It won't work as well. Now, here's a question I got, and I really had a hard time being able to answer this. Will solar panels work with moonlight? Does anyone want to take a stab at it?
It's light, right?
It is light, and we know what the photovoltaic effect is, right? So if on a full moon, shouldn't solar panels generate electricity? Not if the wavelength isn't right. That's a great point. We're getting all of the sun's normal light bouncing off of that white lunar dust. So we're getting most of that light in the right wavelength. It's a little further distance, okay, but there's a big difference with this. If we take a look at the sun is generating about 1.3 kilowatts for every square meter. 1.3 kilowatts. That's of course in space, not actually here on Earth. There's less here on Earth. That's what the sun is generating. But when it goes to the moon and it bounces back, we aren't getting 1.3 kilowatts. We're getting 0.003 watts. So yes, it is technically possible to get electricity from moonlight. Opalco is doing a project, the Baylor Hill microgrid. They're going to be setting out this giant array of solar panels on San Juan Island. That entire system, which can generate megawatts of energy during the moon, might charge your phone. That's about it. It takes an enormous amount of surface area to be able to generate any usable amount of electricity. And we also have to worry with solar panels. Solar panels are interesting. They can actually generate light coming from them. It's going to be in the form of infrared light, but that's energy being lost from the system. So most solar panel systems, most charge controllers, will actually shut off the connection to the solar panel to prevent losing energy over the night. So yes, it could work, but it's not worth it. So solar panels shut off at night, even on a full moon.
Now, if you had solar panels on the moon.
Yes, yes. And actually, solar panels on the moon, this is a fantastic point. Because there is not an atmosphere in the way, you would get 100% of that solar energy coming from the sun. So that's why whenever you see the International Space Station or satellites or all this stuff, they've got solar panels because they can use all of that energy that they get. So what about angle optimization? I was telling you that solar panels work best when they're pointed directly at the sun. I've got this nifty little goofy thing that I've got online. This is a way for you to organize, to angle your solar panel. You just click this onto your solar panel and it says good and best And we can see, it's hard for me to show this, but light is going through this little center hole here. And I see on this target, I'm not sure if you can see the target back here, but then I see that where that light is going on the target. So if I'm aligning my solar panel, I can just clip this on and say, okay, what's the best angle? And then I can position my solar panel the best way. Yes.
Are there such things as angle changers that you could set up things so the solar panel goes?
Ooh, I love it. That is a great question. Yes, there absolutely are motorized solar panel mounts that will track the sun. Now, the fun thing is back in the 90s, when solar panels were really expensive, there was a big emphasis on making sure that solar panel produced as much power as possible. And so you take those solar panels, you put them on a motorized tracker, and you position it, you program it, and you say, hey, the sun is going to go in this arc, so I want you to do that arc as well with your motors. And
Cost benefit, not so.
Cost benefit. If it costs $2,000 for that tracking system just to get 25 to 40% more efficiency, it's cheaper nowadays just to buy more panels if you have the room for it. And even if they're not running at 100% efficiency, you're able to get more power overall than with a motorized system. Yes.
So with your meter, you would do like the optimal time of day or something?
Yes, yeah. Look for solar noon is a great way to kind of figure it out. And because we're here in the Northern Hemisphere, let's see if I can go back to that. In the Northern Hemisphere, the sun is kind of tracking along this direction for the most part. We are going to want our panels to face southward. So if you have a south-facing solar panel, that's going to be best in our hemisphere. For Australians and Kiwis, right, they are going to want to point their solar panels northwards because that's where their sun is in their horizon. If we take a look at a flashlight, I think we all intuitively have seen this. You know that hot spot of light with a flashlight? You can point that directly down, and that's pretty bright. But if you angle that off angle from the surface, it stretches out. There's more, light coverage, but it's not as bright. It's the same thing with the sun. Solar panels will get the most energy when it's perpendicular, right? But if it's off angle, it's going to get a little less energy. I've got this graph. It looks terrible on here, but in the actual presentation, you can see it. This is just showing us how the sun moves around our area. I had it shown from Lopez. So south-facing panels, kind of in this arc, this is the best way to angle a solar panel in our area. Okay, cool. We know how it creates power. We know, does it work on cloudy days and angles, but what do you do with this power once you have a solar panel? Solar panels create DC power, right? Same as a battery. There's a positive, there's a negative. And you can connect this to a battery, or you can connect it to an electrical appliance. Here, this is a floating pump. So you can have this in a pond if you want to aerate that pond to make it healthier for fish, to prevent certain types of algae, things like that. You can have this guy, and it's running off of a very simple solar cell, but you never have to have this connected to the grid. You don't have to run an extension cord out to your pond. That sounds like a terrible idea. But this is an example of a load, some sort of device that is going to consume electricity. This pump that is so beautiful. Why go to Vegas? You can just have your own fountain. Strings and branches. I talked about this, right? You can get a single solar panel, but just like those cells, they work best when they work together. So if you take multiple solar panels, let's talk about series first. A string is best for cost savings, and that's because when you have one solar panel directly connected into the next solar panel, you take the voltage, and you add those together. So a 20-volt panel that can generate 5 amps When connected with another one, 20 plus 20 becomes 40, but 5 does not plus 5. So we're still at 5 amps, but we're at 40 volts, 5 amps, and we're generating 200 watts of power. If we do it in parallel instead, now we don't have them connected one after the other. They're not in a chain. These guys are all coming off of a branch, and instead of adding the voltage, we're instead taking the amperage, the current that each one of these panels generates. We've got 5 amps plus 5 amps equals 10 amps. Now, let's see if anyone has noticed that these systems, while they're different, are actually the same in one regard. Why are these two systems the same? One's doing 40 volts, one's doing 10 amps. Why are they the same?
It's the math.
It is the math. Notice 40 volts times 5 is 200 watts.
Yeah.
20 volts times 10 amps is 200 watts. Both of these systems produce the same amount of power, but one is more current and one is more voltage.
So what's occluded mean?
Ooh, occluded. Thank you for reading the chart. I had totally forgot to bring this up. So an occluded panel is when there is shade or shadow on a panel. If you have them in series, if one panel gets covered by a tree, the entire series suffers. So in a series connection like this, yes, you're getting 40 volts, but when one panel is occluded, this amperage will go down, and none of the other panels can exceed the weakest link, right? In a chain, if you have one weak link, the strength of that whole chain suffers. So when you do it in series, it is best for cost effectiveness, and I'll explain that. But if one panel gets shaded, everyone else suffers. So this is great for making a cost effective system, but if you have trees or occasional shade, your entire solar string will suffer as a result of it.
Does the same thing happen if one of the panels is damaged?
Exactly. Yes, if one of the panels is damaged, everyone else in that string suffers. But in parallel, this is like a single lane road and one car is traveling down center at 25 miles an hour. And you're just like, dude, it's 45, hurry up. Versus you get over to SR20, go to Burlington, and there's 2 lanes. It doesn't matter if that guy's slow, you can just go around them. So with a parallel system, each panel is independent, right? So you can get the benefit of all the panels working together, getting all this current. And if one panel is occluded or one panel breaks, it doesn't affect the entire array. Ooh, I saw your hand first. You go ahead.
When you have an occluded panel and it affects that string, does it affect the other strings in your panel, in your array?
It will affect everything in this series, but let's say that you have another series that is not tied, right? Let's say you can actually combine these. You can do in parallel and in series. Arrays are often done like that.
You could have like two of say 8 panels included, the other 6 are not affected by just your total is
correct.
Less.
Yes. So for every separate thing, right? For every branch in series, every string off that branch, they'll operate at full capacity. It's only that thing on that one string that is going to produce less power. Your hand was next.
Yes, what happens when you have 50-watt panels?
Yes.
Along with 85-watt.
Ooh, great question.
Now up to 390 watt.
Yes, mismatched panels. When you're getting secondhand panels, when you're buying panels at different times in your life, you're going to have mismatched panels. This is some of the experimentation I did, is I have many different solar panels that all have different characteristics. So when you combine them together, you are going to have to pay attention to either the voltage of each panel or the amperage that that panel is capable of. My recommendation for a mismatched system is go in parallel. It means that you have to have thicker wires for all of those mismatched panels, but you will extract more electricity from mismatched panels in parallel than you do in
Where
series.
did you go with all your panels to a bar?
Yes. Yeah. So
And so you're taking from the bar
this,
down to the battery.
this would be the bar, is this junction.
Yeah.
Yeah, so a bus bar is where all of those wires are connecting to. That is a parallel connection, is when you do that.
That's what I got and didn't know.
Ah, yeah, sweet, cool. I'm glad I was able to explain that. Does that answer your question?
Yes, completely.
And you in the back?
So the panels are the same, it's just the components are different, or?
Yes. In this example, all of these panels, we're assuming they have the exact same characteristics. But in a mismatched system, 20 volts, 10 volts, this would be 30 volts in a series. If we're here in parallel and we've got 10 volts and 20 volts, we will be producing not 20 volts. We will be producing 10 volts. We are losing half of the power we could get from this because we have a mismatched panel. Or actually, I'm wrong on this.
Yeah.
Let me step back. 20 and 10, we're gonna get 30, right? We'd be missing, yes, because you're adding these together, but when you go over to parallel, whichever is the weaker, you add up the currents, but then the voltage is going to limit this one. So I actually was still correct. This entire system is going to be 10 volts at 10 amps. We would only get 100 watts of power. So mismatching panels, it's important to understand kind of what's the better thing. Do you want to be limited by current? If this was, let's say, not 5 amps, but instead 2 amps, this can only generate 2 amps. It's only as strong as its weakest link. Over here, it's similar, but it's on voltage rather than amps. So there is this sort of internal argument you have to have with yourself of, hey, if these panels are all close in voltage, then I'm okay with losing out on a little bit of power for having mismatched panels, as long as I can get all that current. But if you have stuff that are all the same or different voltages, but same current, then you'd rather go for something in series. I'm gonna update this presentation with a slide that covers this more. This is a great sort of set of questions.
You have monocrist one versus polycrystal panels.
Oh, hey, look at this. I built this over like the last month, but I forgot all the slides that I have, right? So this covers very lightly this, but I'll talk about mismatched panels. I will talk about different solar panel types, what makes them different, just a little bit later. So if you don't mind holding that question.
It probably does make a lot of sense in this day and age.
It does.
It's what you can afford.
Yeah, okay, that's a great point too. All right, so we've talked, I know it was a little confusing, there was a little back and forth, talking about where does this power go? If we don't have a charge controller, solar panels risk overcharging and damaging the battery. This is kind of to your question of what happens if you don't have a battery, right? These solar panels are generating 20 volts. This battery is a 12-volt battery. That's 8 more volts than it needs. So you can definitely hurt batteries by overcharging them. So if we do that, it's going to get too hot, it's going to damage it. So we don't want to overcharge a battery or even undercharge a battery. So what we want is a device in between called a charge controller. And what this thing does is it regulates the amount of power going to the battery. And so it says, hey, I know you're a 12-volt battery. This is why when we were mentioning you needed a new charge controller for the type of battery that you upgraded to, you had to change out the charge controller so it knew how to keep that battery healthy. So a charge controller prevents damage to your battery so you can have your energy storage system last longer. What about different types of solar panels? What's the difference between monocrystalline and polycrystalline or thin film? We all have seen calculators with those little solar things, right? Those are thin film solar panels. They take a plastic film, they deposit a layer of this silicon material onto it typically through a vapor chamber. But then you can just roll out sheets and sheets of these little solar panels. And so very cheaply, thin film solar panels are very inexpensive, but they generate very little power. They are not very good at converting sunlight into electricity. We're talking maybe 2 to 3% of solar energy.
So I love those things though. That was amazing.
Yeah. For something like a calculator, which is using so little power, it's way easier to charge the battery. You know, the TVs are coming with TV remotes with solar panels on the back of it, so you never have to replace the batteries. As long as you have that thing flipped over, it will not only get light from the sun, but I mean, these things also worked with light from here. They sip energy. So it's important not only to make the electrical device use little power, it's fine if the solar panel doesn't convert a ton. Polycrystalline. In this picture, it's a little hard to see, but there's all these like different flakes of blue silicon material. When they create polycrystalline solar panel, they basically take a whole bunch of silicon, blend it up together, and apply it to the backing material of a solar panel. This is why it's multiple crystals, polycrystalline. In monocrystalline, they do it differently. They start out with a single seed of silicon, and in this bath, they grow this crystal from the bottom up, and they'll bring this thing up. Every computer chip that you've ever used is based off of a monocrystalline structure. It is one single crystal, mono, that gets drawn out, and then they slice it into little tiny thin wafers, and those wafers then get all the stuff on top of it to make it work as a solar panel. So monocrystalline is the most efficient type of solar cell compared to a polycrystalline. Poly is cheaper, mono is more expensive, more efficient, less efficient. Most of the solar panels that you're going to see are going to be one of these two. However, in the last 10 years, there's been some new kids on the block. We've got flexible solar panels. It is kind of a combination of these two. It is a crystal that can take some bending. So these are great for putting on an RV or a boat where you've got a curved structure and you just want that solar panel not to stick out weird angles. So you can attach these types of solar panels to a van or something like that, and it will follow along the curve without breaking the structure. They're meant to be flexible. We've got bifacial solar panels. What do you think bifacial means? Okay, great. Yeah, you got it. There's two faces of it. Imagine, what if we got rid of the backing material on that silicon or that solar panel? And so now sunlight can hit this side, but it can also hit this side. You double the ability for that solar panel to collect energy. Now, the really nifty thing that we're finding out from research in the last 2 years is with this new technology of solar panel, rather than having it angled up at the sun, if you do this vertical orientation for the solar panel, it seems like when the sun is right above it, it's not getting any energy. But what it does, it collects the dawn and the dusk energy really well. For agrovoltaics, has anyone ever heard of that term, agrovoltaics? This is this concept of taking solar panels and putting it in an agricultural setting. You have farms where instead of all that fencing that we typically see, imagine if all those fences were solar panels instead. Still keep the livestock from leaving the property, but now it collects energy all throughout the day in ways that a solar panel pointed at the sun isn't going to be best suited for. And as solar panels get cheaper and cheaper, this type of thing, I think we're going to see more and more of it. In solar panels, they only create power during when the sun is out, and they work best at solar noon. For all these states that are building these giant arrays like the one on Baylor Hill, we're doing all these big arrays. We have all this power at the time when people don't actually need to use all that power. So these types of panels are really good at getting power at the early and evening hours when people are getting up for breakfast and doing their laundry at night and doing all their cooking. So we're starting to see that we're getting smarter about how do we orient these types of panels so that way we can get the most of our solar energy. And the newest kid on the block is perovskite. I will tell you, I don't know much about this. I just know it's a different type of crystal lattice structure. It has kind of this reddish color to it. This is the new kid on the block. It is theorized to get even cheaper than these while being just as efficient. So we're going to see solar panels get even cheaper.
And is it also really small then? Because it looks really small.
It looks really small, the same way that a solar cell, you just need multiple of them connected together in a panel. So we're just looking at one cell. So we've learned about how solar creates the photovoltaic effect. We learned about angles. We learned about moonlight and cloudy days. We learned about where does this energy go into a charge controller and into a battery. But then you might have a question of, well, how do batteries work? I've heard of things like lithium ion and lithium iron. What the heck does this stuff mean? So let's start off with charge controllers, right? You need the right charge controller to charge your battery. So solar panels often produce power higher than what batteries need, right? That's at 20 volts to a 12 volt battery. There are two types of charge controllers. You have pulse width modulation, PWM, and you have maximum power point tracking, MPPT. Quite simply, if we have a 20 volt solar panel and a 12 volt battery, and a PWM, pulse width modulation charge controller, is just going to send out little bursts of energy, and it's enough for this battery. Even though it's receiving 20 volts, it's not constantly at 20 volts. So over time, it's going to be 12 volts because we've pulsed that energy to the battery. That keeps it healthy. It's not getting overcharged. It's fine with getting something a little higher than what it likes, as long as over time, it's not getting more charge than it needs. So PWM charge controller will just send out little pulses. A MPPT will, they have these algorithms in the little boxes. They're much more complicated circuitry. It is not just sending pulses of energy. Instead, it is trying to find the maximum amount of power that that solar panel can generate, and then it will send that to the battery in the format that's healthy for the battery. So an MPPT is more expensive. So when you're online and you're looking for charge controllers, keep in mind that sellers will try to trick you. There are scams for products. MPPT typically costs $100 for one of these boxes. A PWM controller, it's like 20, 30, 40 bucks. They're way cheaper. So here I am on Amazon, and we have a MPPT solar charger for 20 bucks. If it sounds too good to be true, it probably is. So if you look in the comments on this, people will say, hey, this is not actually an MPPT controller, but it works fine as a PWM. It's a PWM where they slapped on a label and said, it's MPPT, trust us. It doesn't have the circuitry to do this. And you will see, this is so common. This is a commodity charge controller. Look at this guy. So it's like the same thing, right? There's 2 USB ports, there's 3 buttons here. This is a PWM controller. So the fact that this thing says it's MPPT, stinking liar. Okay. What does a real MPPT controller look like? This is a Renogy MPPT controller. It's capable of doing 40 amps. Look at that cost, right? We were looking at $20 versus $160. So if you're on a budget and you see MPPT for 20, you're gonna get tricked into buying one of those cheap, wrong controllers. MPPT is the best way for you to get as much watts out of your entire solar panel system, your solar array, as possible. Because remember, it isn't just trying to do pulses of energy. What it's doing is grabbing as much of that energy and just providing it in a format to the battery that the battery likes.
You know, I have one of those.
Oh, you do?
I've had it for 12 years.
Yeah.
And it's just bulletproof.
Yes.
I mean, it is wonderful.
Yeah, that's awesome feedback. Thank you.
And that's for your house?
No, it's for my camper.
Okay.
Mm-hmm.
That's where I started out with camper. So.
And we all start somewhere, right? So, and this is part of this journey, is that you start small and then you grow and you say, oh, well, I've got $1,000 here. Let me go do this, this, and this, and go upgrade my system or go do another building.
When you're just starting out, you get something that doesn't give you headaches and screw up all the time, where you're not making phone calls.
Yeah.
Then you just ignore it.
Yes. And that's why I think that the DIY system, I mean, whenever my parents come to the island, I'm like, Mom, look, I upgraded this. Look at what I could do. There's a sense of pride with doing it yourself and being able to build these things. And right with the repairability, the upgrade stuff, when you understand it, you're able to go through and really be proud of this work that you do. So we've got charge controllers, and we know PWM or MPPT, but now we've got to understand battery types. And batteries have been around for over 100 years. So there's a lot of different technologies in the lead acid battery space. We've all heard of lead acid batteries, right? Well, I have one here. This is a lead acid battery. This is the type of battery that's going to go in a car, a golf cart, whatever, right? It's got 2 posts here. It's all made of lead, and there is a fluid in here, a liquid that is the electrolyte, that is acid. So that's why it's called lead acid batteries. You'll also see these called PBA. Why is it called PBA?
PB is the symbol for the.
That's right, and acid just being A for short. But you're totally right. PB, atomic element for lead, originally comes from the Greek word plumbonium. That's where the word plumber comes from, because they work with lead. There are different types of lead acid batteries. You will have flooded batteries. These are the types of batteries that you had to refill occasionally. You had to top it off with some water in order to make sure that the electrolyte solution would cover the entirety of the lead plates inside the battery. More recent, like the last decade or 2 or more, we've been doing sealed batteries. You'll see these as SLA. Anyone want to take a guess of what SLA stands for? Awesome. Yep. So you do not have to worry about refilling these types of batteries. There are AGM, absorbed glass mat batteries. Rather than doing a type of structure that you fill in with lead, these plates of lead, what they do instead, or I should say, they typically have a separator between those lead plates. And that separator would be made of paper. It'll allow liquid to pass through, but it would prevent the lead from directly touching each other and short circuiting. So AGM batteries would take this fiberglass type structure and put it in between the lead plates. And what this does is it provides more strength and rigidity to the battery. And I'll get into why that matters. We also have gel batteries. Rather than a liquid, we have something a little goopier. And so the electrolyte is a gel instead of liquid. And then we also have spiral or tubular batteries. If you've ever seen like Optima batteries that are in kind of these cylinders, those are spirals. They take the plate and they roll it up. That's what they do with the spiral or tubular battery. So the reason why I'm covering all of these is if you want to build a lead acid battery system, an energy storage system, they are cheap. They're easily available. You can go buy them at most stores, right? You can go to and Walmart. You can even get batteries here on island that are going to be some of these types. There are some cons. These types of batteries typically can only be discharged to about 50% unless they're deep cycle batteries. This is a car starter battery. It is meant to produce a lot of current for a short amount of time, just to start the car. After that point, all that gasoline and combustion will then run an alternator to then recharge this battery. It is meant to be a sprinter, not a marathon runner. But when you are powering your home or an off-grid cabin or whatever it may be, you want a marathon runner. You don't need a sprinter. So some batteries, like absorbed glass mat, gel, and spiral, are going to be typically deep cycle batteries. The reason why these types are going to be deep cycle is when you discharge a lead acid battery more than 50%, it experiences buckling. All of the lead inside that battery will start to expand and it pops out of the structure, the lattice that it's in. And as that lead goes down, it's no longer part of the electrical circuit. Your battery gets weaker, it has less energy storage, it starts to break. So you don't want to take a lead acid battery further than 50% unless it's deep cycle. Now, why do these help? Well, with absorbed glass mat, rather than having paper separating the lead, now you have this strong glass, and so it can prevent the buckling. Or if you have a spiral, that shape of those plates will help prevent buckling. This allows you to use more of the electricity stored in that battery throughout the day. So if you are going to be using lead acid, I would encourage AGM or anything that says that it's a deep cycle battery. Just make sure it's going to be like an AGM, a gel, or a spiral. You can do SLA batteries that will have thicker plates, and that can help make it a deep cycle battery because those thick plates are expensive, but they can resist that buckling.
You know, I'm finding it, I'm still only getting out of AGM batteries, maybe 50%.
Oh, dang. And how old are those batteries too?
Well, when they were new, they still.
And you said 5 years ago?
Well, these are all 5-year-old batteries.
Oh, okay.
But they don't necessarily do what they say they will.
This is, I think, one of the biggest risks with lead acid is you can size out the system, but you're never going to get all of that system with lead acid. Yeah. The advantage of this is if you have a whole bunch of batteries laying around, you can recycle those batteries in essence by integrating them. You had a question in the back.
Well, that was kind of my question because at the dump, someone once said, oh yeah, sometimes they just pull the batteries out of the boats after a year.
Yeah.
And they're there at the recycle center and they said, just check them and there's some good batteries there. I won't even.
Yeah. There are 2 tools that you can use to check batteries if you are going to recycle batteries from the dump. I'd encourage this. I'll get into some of those tools, but just very briefly, I want to talk about flooded batteries. Has anyone ever used a flooded battery?
Yeah, I used to refill.
And one of the fears with a flooded battery is they can off gas, and they off gas water is hydrogen and oxygen. Well, when they off gas, they will have hydrogen gas, which is very combustible. So you have to worry about sparks when dealing with a flooded battery. So there is a bit of a fire risk with flooded. So I personally would stay away from that because a fire is catastrophic.
They're also carcinogenic.
Yeah. Yes. So probably best to have a sealed contained system like this battery, for example. It's got a little viewing port to tell you where that electrolyte solution is in the battery. So if it starts going down, you know that your battery is no longer good. Oh gosh, this thing is so heavy.
You know about like charging, I once heard like for the Prius car that it should be that 80% was optimum versus charging it all the way to 100%.
With each of these battery chemistries, there is kind of a healthy way to charge and discharge the batteries, especially when we start talking about lithium ion. There is definitely a healthy charge, state of charge that you want to do with that. Let's talk about lithium ion. So these are really popular. We've seen lithium ion in cell phones, in e-bikes, in electric vehicles. We've even seen them in stationary storage applications. We're moving to different battery chemistries now, but these lithium ion can either be these big battery banks, right? Or it can even just be these little cells connected together. Laptops, your laptop is typically using these lithium ion cells in this format, just kind of stacked together in series to produce 19 volts. You can, and some people do, they will either get a wholesale of a whole bunch of lithium ion cells and they'll check each one of them, they'll measure the capacity and they say this one's good, this one's bad, and then they'll do it yourself, build their own energy storage system. It's entirely possible, there's lots of resources online on how to do that. There are disadvantages of this from an environmental standpoint. Lithium-ion batteries can use rare earth metals. Not only lithium, but you'll have nickel, cobalt, manganese, these other elements in order to improve the energy characteristics of this battery. If you're mining for this stuff new, there's some different battery chemistries we might be able to push you towards. But if you're recycling these cells, it's way better to reuse and repurpose an old battery than it is to go through the process of grinding down the material and then incorporating it into a brand new battery. So these lithium ion batteries also need a BMS, a battery management system. What they'll do is they will try to make sure that each one of these batteries is healthy at the right charge voltage, etc. Right? Your charge controller will send that to an entire battery pack, but a BMS will make sure each one of these little batteries is at the right level. Think of a BMS like a charge controller for each individual battery cell. Lithium ion is great because it's lightweight. It has the most energy storage. This makes it great for an electric vehicle where you're concerned about how heavy the vehicle is and you're concerned about how far that vehicle can go. The disadvantages of it is it's expensive. Lithium ion is not very cheap. There are fire risks with lithium ion. If they're overcharged or if they get punctured, they can short circuit and do something called a thermal runaway where they catch on fire. Do it yourself is complicated. There's a lot of stuff that you have to do with it. It's possible, but it is diving into the deep end of energy storage. And then you also have limited temperature operating range. I like to tell people lithium ion are a lot like people. You want to stay in about 70 degrees. That's what you're comfortable with. But if your lithium ion battery sitting in 120 degree weather or a -10, lithium ion doesn't do well in those extreme temperatures. The same way that if you're outside in -10 for more than 5 minutes, you hate your life. So what about some of these other things? We've heard of lithium ion, but lithium iron phosphate. Li, lithium, Fe, iron, P, phosphorus, O, oxygen, PO for phosphate, lithium iron phosphate. So these are very popular nowadays for stationary energy storage. Every Tesla Powerwall, every energy company that is doing grid storage, they're all moving to lithium iron phosphate. This battery chemistry doesn't use the nickel, the manganese, the cobalt. It's just lithium and iron and easily available phosphates. So it becomes cheaper than a lithium ion. So it's the best value as of today for energy storage. It can go up to 5,000 charge cycles. What is a charge cycle? From 100% to 0%, 5,000 times. That's a charge cycle, right? So when a lithium iron phosphate can do 5,000, what if you only use 20%? Well, you've only used 20% of a charge cycle. So when we are talking about a charge cycle, if you only do 20 and then you do 30 and then you do 50 over 3 days, that's one charge cycle. So imagine 5,000 of that means that you can have one of these batteries last for 10, 15, 20 years. So lithium iron phosphate is great for that. Cons. You saw that battery, the EcoFlow Delta, you lifted it. It's heavy. It's a lithium iron phosphate battery. That iron makes it so heavy. So it's very heavy, similar to like a lead acid battery. Go ahead.
But you can get more.
Yes.
In a smaller space.
Yes. For the amount of energy it has. Yes. Its energy density is way better than a lead acid battery.
And it's cheaper than lead acid batteries.
Ooh. Yeah. So. Yes. For my solar shed, I bought 2 100 amp hour, really 1 kilowatt hour batteries. I bought 2 of them for $400. And this is more energy than I need for my one e-bike. My wife has an e-bike as well. We can charge both of our e-bikes overnight and still have about 30–40% of our total energy left over. So when the sun comes up, it recharges those batteries, never having to worry about running out of power. So lithium iron phosphate is cheaper, it is heavy, but it is energy dense compared to
safer.
And it is safer, it is. Less fire risk. You do not experience, if you puncture one of these batteries, you don't have the same likelihood of this thing catching on fire and then not getting put out until it's dead.
So that's also, I mean, there's all those rare earth minerals that are so dangerous that the lithium uses, that these don't.
This still uses lithium, but it doesn't use as many of the other expensive or controversial elements. Now, if we want to get into real safe and environmentally friendly batteries, let's talk about sodium ion. This is the new kid on the block. A sodium ion battery looks like this guy. Now I've done a little bit of work to this. So this is a sodium ion battery. This is salt and aluminum. The entire structure of this only uses salt and aluminum. It means that salt is really available. We are sitting next to an ocean of it. And aluminum is also an incredibly easy to get material, both new and recycled. You know, all those aluminum beer cans that I keep recycling, they go right into a battery. It's pretty nifty. Now, the thing about this is they are expensive. They will get cheaper over time as factories build the quantities to reduce down the cost of this. So I expect in the next 5 years, we'll see this battery chemistry become more readily available. These batteries are also nifty because even if they get fully discharged, you can't do this with lithium ion. If you go past a certain point in voltage, lithium ion cannot recover. The same way that if you really stretch your muscles, you know that next day you are feeling super weak and you do not want to lift anything, right? These guys, they can work super hard, and you can just charge them right back from 0 volts. Very nifty stuff. There's no rare earths, no lithium. It's very fire safe. I call it goof proof because even if you over discharge the battery, you can still safely recharge it back up. And it also has a really great temperature operating range, really extreme heats, really low temperatures. The problem with this is this could get used for some transportation applications like electric vehicles, but it's not energy dense. So you can take up the same amount of space, the same weight as another one of these battery chemistries, and you're only going to get about a third of the range. And when you're shopping around for a car and 200 miles is already too low for a lot of people, it means that sodium ion is not going to be great for EVs, but it could be great for grid storage as long as it's cheaper per energy unit compared to lithium iron phosphate. Right? Lithium iron phosphate is what we're using for a lot of grid storage, house storage. Maybe sodium ion can come and displace that once it becomes cheaper. It's expensive, it's limited availability. I told you I only found one company that was willing to give me a battery of this new type. I've got all this stuff connected to it. I'm going to kind of take a little bit to talk to you guys about this. Also, I realized we've got 5 minutes left in the class. Do you guys mind if I continue and go over our allotted time? I have this room until 3 o'clock.
I'll stay a while more.
Okay.
It's interesting.
Sodium ion battery, here I've got a fuse. So inside here, there's one of those little car fuses. So I've got a fuse in here to help make this safe. I've got this cigarette lighter adapter that's connected directly to the battery. So this is 12 volts from the battery plugged into. I have this inverter that I had in my car for when I go camping and I need to inflate the air mattress, right? I've had this thing for like 20 years. But I wanted to say, hey, I need an inverter, and this is an inverter. Hey, look, I made my own all-in-one system. So I don't have to plug around that heavy guy. I can carry this. So this is an example of a do-it-yourself energy pack, right? I've got the battery, I've got the inverter, I have the safety components all to it, and this is not bad to carry around. You know, I can do this. It just only has 366 watt hours. It's not a lot. It can do, run a lot of different electrical things, but for my e-bike has about 750 watt hours. This can only charge my e-bike to half. So it's not great for completely replacing a lot of my stuff, but I thought this was very nifty. I'm waiting, they're gonna give me a bigger model. They're gonna have like a 180 amp hour. Yeah, they give it to me for free because I'm like teaching people stuff. So I'm waiting for them to come out with a new model which has more energy storage. It'll be a bigger size, of course. But that's one where I'm excited as well.
Did you hook that right up to your solar panel?
Yes, I don't hook it up directly to the solar panel, but I can use a charge controller, solar panel charge controller, and that goes to the battery. So that is something that I can do to recharge that, and then I have a complete off-grid system that I can carry around, right?
And I can carry it out.
Yes, yes. Yeah. Cool, we talked about battery chemistries. We've talked about a bunch of stuff. Well, now that we have all this stuff, how do we actually turn it into usable power? So we know that a battery creates DC power. There's a positive, there's a negative. There's the red, there's the black, right? Red is typically positive, black is typically negative, but we want this to power laptops and blenders and microwaves and a whole bunch of stuff. So in this diagram, we see that we've got the solar panel to the charge controller. Charge controller is making sure the battery is healthy. And then we have an inverter. Even though the charge controller, this guy has these two little terminal blocks with a light bulb on it. You could put lights or other electrical appliances connected to this part. but these charge controllers really don't want to handle a lot of current out of this area. So instead of connecting our inverter to the charge controller, we instead connect the inverter directly to the battery. And so then we don't have to go through this, which is limiting how much power can go through these two terminals. We instead connect it directly to the battery. And part of this is when you start up that inverter, it has something called high inrush current. When it starts up, it uses a lot of power, and then it starts to slow down. Same thing with a refrigerator. If you have a 12-volt camper fridge, you're going to connect it directly to the battery. And that's because when you first start up that fridge, that compressor motor has to run and it uses a lot of current. And a battery can handle that, but the charge controller can't. So there are two types of inverters. We've got the one that's attached to that sodium ion battery. That is a modified sine wave inverter, or the more expensive type are, oh gosh.
Pure.
Yeah, that's supposed to be pure. A pure sine wave inverter. So when we look at an alternating current goes here and then it goes here. This is what's alternating in that current. A pure sine wave inverter will make a pure sine wave, right? The name says it all. A modified sine wave inverter can't do this perfectly smooth curve and instead sends out pulses of electricity. The same thing with like that pulse width modulation charge controller. It sends out pulses that pretty much equate to kind of a sine wave. This is fine for powering electronics, a laptop, a cell phone charger, no problem. Those electrical circuits are designed to get kind of noisy power. But when you have motors, motors want really smooth, continuous power. And so a pure sine wave is best for running electric tools like a saw or like a chop saw or a miter saw or a corded drill, a vacuum cleaner, all of that stuff will like a pure sine wave inverter than it will like a modified. You certainly can run those devices, but you may end up damaging them over time. So it's important that you get an inverter based off of what you plan on hooking up to it. Yeah? For your idea of the mini split air conditioner, it's got a motor in it. You're going to want to get a pure sine wave inverter for powering that thing. I talked a little bit about charge controllers and how that 12-volt load directly connected to the battery and not, sorry, I'm losing my words here. The electrical appliance, whatever you have connected to the charge controller should be really limited. This is great for like lighting, interior lighting. This is so low power. You're fine with doing something like connecting 12-volt LEDs directly to your charge controller. You can also program that charge controller to do things like turning on the lights when the sun goes down automatically. Pretty nifty stuff. If it knows that the solar panel isn't getting any more power, then it turns on the lights. This is really best for these kind of small load type things. You also saw that there's those USB ports. You can have it where, hey, you power this thing off of USB only while it's sunny or only while it's night. So those are low sorts of power applications that you could use with a charge controller. All right, we've learned about solar. We've learned about batteries. We've learned how it makes the power. Well, now if you're going to do it yourself, how do you do it safely? So to avoid electrocution, it's important that you never touch a positive and a negative with your bare body. If you do it on a single arm, it's going to hurt. If you do it across two arms, that electricity will run through you and to your heart, and that can kill you. So it's very important that if you ever do electrical work, you try to make sure that either you're wearing protective gloves or the system is grounded, or you just make sure that you only touch one terminal at a time. Never hold the battery while you're clipping in the other side. Make sure you've got only one hand on that thing, right? Make sure that the battery is in a dry location, off of the ground. You don't want it wet. Water and electricity, yeah. And you should also cover exposed terminals. If you've got that positive and negative, like that lead acid battery is right now, that is a potential danger for electrocution. So you should get covers that go on top of those terminal posts just to make sure an animal doesn't touch it, a child. You never want anyone getting hurt from any of your things.
Are you saying a 12-volt can kill you?
Yes, a 12 volt with enough current can absolutely kill you. And if you design these systems where they can store kilowatt hours of energy, it absolutely is possible. The voltage only determines whether it can break the skin barrier into your body. And let's say that you're particularly sweaty that day. That means that your electrical resistance in your skin is lower, making you more conductive, and even a 12-volt battery with a high enough current could kill you. Wires. Remember when I talked about series versus parallel panels, and I said if you do it parallel, it's going to cost you more. Well, why is that? Well, when you increase the current, the amperage, you have to use a thicker cable. And of course, when we created the standard of the American wire gauge back in the 1800s, we said 20 is the smallest. And as you go down to 1, that is a bigger, thicker cable. And then we went, oh wait, we gotta make bigger cables than what 1 is. And so then you get into really crazy numbers that describes how thick that cable is. So remember, with AWG, or the wire gauge, the bigger the number, the thinner the wire. And if you have a thin wire, it can only handle a certain amount of current before it starts heating up. The resistance of that cable will make it hot, it can melt, it can start a fire. So when you have a parallel solar panel where you have a lot of current, you want to make sure that you have thick cables so you don't start a fire. But thick cables cost more. That's why a parallel connection is going to be more expensive than a series connection, but parallel has the advantage of avoiding occlusion issues or a broken panel or whatever that might be. So there is a cost to this. You can find stuff online. There's code books and stuff like that that talk about what is the rated amount of current and voltage for the type of wire that you have. It's important that you make sure that you size your wire correctly. Oh, the wire I bought for my do-it-yourself system, I've got this red and black wire right here. I got this from Sunset. You can just buy it by the foot, right? You can just buy the amount of wire that you need and kind of the size. Does anyone want to see these guys? I know it's not very fun to look at. They're just wires. There is also aluminum versus copper. Copper is a better conductor than aluminum, but aluminum is cheaper. You can go for aluminum wires, but you're going to have to get a thicker wire to compensate in difference to what a copper wire can do. There is also solid core versus stranded. Stranded is a bunch of little thin wires versus solid being one thick wire. Stranded is more easy to bend and flex, but it can't handle as much power as a solid core wire can. And especially as you get to the thicker cables, they are going to end up being thick stranded cables.
You know, current loss over distance is an issue with sizing wire.
Yes, it absolutely is.
I've seen it in real life.
I want to address that point. I'll get back to that, but you have a question?
12 volt, it's much better to use the stranded wire than the solid.
Yeah, I will say that connecting terminals is easier on the solid. It's easier to like do the soldering and stuff, but you're absolutely right with that stranded being better for making those connections to the battery. And typically like, and one of those wires that I told you, those are stranded anyways. They're not going to be solid core.
You know, I've heard that the difference between stranded and solid is there's so much more surface area on the stranded wire that it can carry electrons happier.
I think that the thickness of the cable means that there are no gaps in a stranded system, right? A solid core is all continuous copper.
Yeah,
And yes, it travels, I believe on the surface, on that surface area, we're starting to get into an area I'm not very familiar with. So you very well might be correct on this. Really, you're only going to see solid core on very thin wires. When you get to thicker, it's going to be stranded anyways. Oh, the point that you were making, oh gosh, I lost it.
Distance.
Yes, the distance aspect. When you have a direct current running over a long distance, like from your solar panels all the way down to your charge controller, and we're talking tens, hundreds of feet, the length of that cable will have resistance. And so the longer the wire is, the more resistance there is in that cable, and there are what are called line losses. You will lose out on potential power because it's creating heat in the wire. So having short runs of wiring is better than long runs. But if you do have a long run, having a higher voltage can overcome those resistances. So if you have panels in series, that high voltage can overcome some of those resistances in the wire.
Can you also increase the wire gauge?
Yes, you totally can. It just costs more. It's a more expensive thing to have a thicker one. Thicker ones have less resistance, even for the longer runs. Increasing the voltage, increasing the gauge are both strategies to avoid line losses. Fuses. I showed you the one on that little sodium ion battery. That fuse is essentially a wire that is meant to break at a certain current, a certain amount of electricity flowing through it. You want this thing to break before your thing catches on fire. So having fuses are really good in a system. You should have like this. This is a solar panel fuse. So you have this fuse in line with all of your solar panels before they get to your charge controller. You can have these types of like these car bladed terminals. You can get some of these where you wire them directly onto a battery. There's a lot of different fuses. The point is, anywhere that you have a wire, you typically should have a fuse, and that fuse should be slightly lower than whatever the rating is for the wire or for the device. You want this thing to break first, rather than your battery, your charge controller, your lights, etc. Switches. Oh, check this guy out. Look at this guy. This is a big beefy switch. Look at these little screw terminals. You can break out these sidewalls, put in wires, connect them here. And all this is it's simply an off-on switch. And it's just meant so that way when I am doing any work on my battery, if I'm going to take off one of those terminals, if I'm disconnecting the battery, I always turn it off at the switch first, because this will safely disconnect the circuit. So when I'm pulling that cord off of that battery, it doesn't cause a spark, right? So if I use this, I can make sure that when I work on all my electrical stuff, it's safe. When it's off, I know it's safe. When it's on, I know that that power is all connected again. So switches are really nice. Over here, this is one that connects to solar panels, because remember, the photovoltaic effect happens regardless of whether something is connected to it or not. So if I'm gonna work on my solar panels, I can turn this off, and then I disconnect all of that live electricity that is coming from the solar panel. So this makes it safe to work on solar panels. Crimping. If you're going to make your own connectors, you are going to have to crimp a connection. So I took this little RC power analyzer, so you can get this on Amazon for like 20 bucks. And I added my own solar panel connectors, here on the side. So I have solar panel connected to this, connected to charge controller. And what this can do is on the little LCD, it will tell me how much power my solar panels are generating. It's very nice for me to just easily plug this in. It's got these little spindly wires here, so I can power this from the charge controller so it stays on even when the sun is off. There's technical reasons for why that is, but the main part of this is if you are going to add your own connectors, either to a battery house, little ring terminals, or if you're doing these MC4 solar connectors, you're going to be crimping, and it's not very easy. It's not very intuitive, but there is a really handy YouTube video I've linked that can explain this out in more detail so you can learn how to crimp correctly. Cheap tools, cheap parts, it doesn't have to be that difficult, but the point here is that you have this stranded wire in this metal sheath. When you crimp it, there is this tooth, and here is the seam. When you push this up, it is going to fold these wires into that connector, kind of like this. So this is a nice, strong, healthy, crimped connection. The better the crimp is, the less heat it will generate, making it safer. So crimping it properly is important. All right, we're getting to the end. You guys have had to go through a lot. Here are some extra things I just want to toss in for your reference. When you get solar panels secondhand, you can learn more information about it. It will certainly have a little label there. It's really difficult to see, so let's blow it up. So most solar panels will have this label with a bunch of gobbledygook on it. But if you know what to look for, you can make sense of it. We see here that this is a 100-watt panel. When you connect a multimeter to it to measure the voltage, we see that it can produce 23-ish watts in direct sunlight, and it should create about 5 amps of current in direct sunlight. Now this, of course, is called open circuit voltage and short circuit current. What this means is when we hook up our meter to it, there isn't an electrical load on this, it's just measuring stuff. So these are the values we should see when we're measuring stuff, but when we actually hook it up to a system, we should see these numbers: maximum power voltage, maximum power current. We've got 20 volts times 5 amps, that's 100 watts. So that's why this is a 100-watt panel. So when you get a secondhand panel, you can take a multimeter, like this guy. I bought this on Amazon a long time ago. You can use this for a car, like if you want to check out if your car battery is right. Put this on the positive, put this on the negative. It's color-coded, red and black. So you can do that to the solar panel, and if you get it flipped around, it's not a problem. It's just going to show you a negative voltage rather than a positive voltage. So when we connect this up to this panel, we should be seeing in sunlight that panel is generating about 23 volts. And this multimeter has a feature where you can take up this red lead, move it over to here, and now it's a fused circuit, so you can switch it over. Well, I don't have to go the other way. You can switch it over to measure the current. Hold on. Hey Rachel, I'm sorry, I'm still teaching the class. Yeah, I thought we were going longer than I thought. Sorry. I'm gonna be here for like the next half hour. Okay. Thank you. When you connect it over to here, this will allow your multimeter to tell you how much current that solar panel creates. So if you get a secondhand panel, check the voltage, check the current, and then you can say, oh, I need to put this in series in my solar array. Or, oh, I need to actually have this separated. This should be on a parallel branch circuit. So this is a way that you can test secondhand panels. The solar connectors that I was describing before, these guys are called MC4 connectors. They are a water-tight connector. So when you plug them in, they will make a water-tight connection. So you can have it exposed out in the rain, no problem. So that's this type of connector, super available online for very cheap. All you have to do is crimp it yourself and watch that video. It will help explain how to do the crimping. You can make your own solar wires. You don't have to go buy a pretty one where, oh, this is way too long or this is too short. You can get the exact length that you need and attach your own ends. Now, this particular guy, I'll take off this Velcro, has this other end to it. This is called an XT60. You're gonna see this type of connector a lot on those all-in-one systems. This is how the solar will plug into the all-in-one battery systems. Those all-in-ones, the reason why they call it all-in-one is they're a charge controller, an inverter, and the battery all in one. So this is the plug that you're typically gonna see, XT60. This, so weird, from Take It or Leave It. I got this charge controller. This is the cheapest looking piece of something I've ever seen. I've never even seen these connectors. These types of connectors are called SAE. And so with this type of connector, I'm able to hook into this guy. I looked online, there is no information about what type of voltage I need to put into it. So I looked up online, I found some more information, and I went out and bought a 12-volt panel, right? So this is 12 volts. I attached my own SAE connector to it. And so I can just very easily plug in. There we go. I've got a 12-volt solar panel to this charge controller. Well, this solar panel is so
That was like on my electric bike that I got, with the way it connected the motor to the battery.
Oh yeah, this type of connector. Yeah. Oh, nifty. Yeah. And then there's also ring terminals. This is the ring terminal. There's other types of terminals as well. But this is really nice when you have a battery like this guy. Ring terminal can go into a post like that. And so then you can screw it on. You can use a wrench or whatever. So ring terminals are typically ways that you can connect to a battery really securely. You can make that a nice tight connection. Loose connections are bad because they will create heat, and that's a fire risk.
Lithium batteries are that way.
That the sodium battery or?
No, the lithium ion.
Yeah, like that, the big one. So what about the lithium ion?
It comes with a screw. It
Yes.
screws in, not a hook.
Yes, and it depends on the battery, but the ones that I have, lithium iron phosphate, are a screw post. And so those ring terminals allow me to tighten. But I've seen lithium iron phosphates where they have other types of terminals. So not all of them, but most of them.
Okay.
Screw terminals, these are nifty. You stick a wire into it, use the screw, and it tightens a metal clamp down onto that. It's very easy. There's no soldering, there's no new connections. You just take a bare wire, stick it into the thing.
I should mention, that's the connector that's on that Renogy.
On the Renogy, yes.
And it's a pain in the ass.
Yeah, I can agree. There are tricks to how to make it easier, but with this screw terminal, it makes it very easy for me to just screw in and unplug and plug in a thing. You don't have to have the specific type of connector that the thing has. Now you can just stick bare wires into it.
Yeah, but it's not very well made. That was one of the shortcomings.
All right, guys, we have made it to the point of the class. Just only 25 minutes later than maybe I would have liked, but we have the opportunity to play around with some of these things. So I'm going to start moving some of these devices outside, and we can actually experiment around and play around with this. If you are not interested in doing that, this can be the end of the class for you. I'm going to be around with questions and helping you out, but for the most part, this is everything that we intended to cover.
How we
You know, I
find you
want
in the
to,
future? Email?
If you want to get ahead of me in the future, you can reach out to me at andrew@lopezislands.tech.
Were you involved in over there at the swap had a bunch of, are you that?
Yes,
Andrew?
I am that Andrew. So I was in charge of the remakery, which I think is what we were describing back there.
Yes.
Yeah. So yeah, you can reach out to me for questions, advice. I'd be more than happy to help you design your system. If you have questions and things like that, I'll help answer that too. Of course, I'm not licensed, but
I gotta
Thanks
take
very
off.
much.
If anybody's interested in being part of the solar panel run,
Oh,
you
for,
know,
are you going?
what is a solar panel run?
it's like a beer run.
Okay. Okay. Yeah.
What is
So if we
it?
get it together, maybe we can work it out. Like,
I think he's talking about purchasing a bunch of
Yeah,
solar
so-
panels in bulk and then
Well-
distributing that out.
Do I have to read them?
Thank you, Andrew.
You're welcome. Thanks for attending.
every 2 hours.
I'm going to go ahead and stop the screen share. And I think
I mean,
So,
I'm always going to build
Andrew,
a-
is there resistance to solar energy like the power companies? Because if everybody did